Hello, it's Keith here, and this is lesson 4 of the Photon series of my 68000 assembly programming tutorials. Photon is of course my little Tron clone, you can see it just here, and this is basically a game that only uses pixel plotting for all of its graphics. Obviously the lines are drawn at the pixel level, you can see they're drawing away there, but also the title graphics and the fonts are all vector based, and the line routines themselves use an individual plotting routine, a PSET routine, to draw the lines and the text and the title screen. So to port this to a new system, all I need to do is create a new PSET routine and a new point routine to read the pixels back from the screen for the collision detection, and the game will pretty much work on a new system. And so this is the series where we go through that, and it's a nice example of how to do plotting and reading from the screen on each system. Now, before we go into the code, I just need to show you a few things about the game because they come up. When I press a direction, I have to release the direction and press again. You can see that there before I can move, and that you will see that in the code for the key reading. And also there is boost mode, and if I hold down the fire, you can see I'm moving much faster, and this allows me to catch up with the enemy, and we'll see that in the code. So I just needed to explain those before we went into the code. Now, the x68000 is quite an interesting system. It's a 16 color system in the mode we've got it set up. It's got a slightly odd screen size, 256 by 240, but this game, because it's all vector based, you can resize the game to any screen size at all, really, relatively speaking. So we're able to use that full screen area. The other thing is the memory layout's quite odd, and it's actually quite convenient. It's just a little bit strange. Basically, each pixel uses a word, even though only a single nibble is used by that word for the pixel, because it's 16 colors. So we'll see that represented in the reading, but as I say, very straightforward to work with. Let's go over to the code and let's take a look. Okay, so here is the game code here. We're going to go over the new stuff and the stuff specific to Photon, but we're not going to cover the stuff that was covered in the simple series and also in the Yquest game. The joystick reading routines haven't changed, and some of the screen routines are identical. We're only going to cover the new stuff. So if you need to know more about the other stuff, please see the simple series, the bitmap and the joystick routine, and the Yquest game where I covered them in more depth. Okay, so the first thing we're doing here is we're defining the colors. The game sometimes has to work with fewer colors than is ideal. The ideal is 5, that's black and 4 colors. In this case, we can use them all because it's a 16 color system, so they're all just mapped 1 to 1 there. Then we've got the screen size definitions. The 256 by 240 screen is being defined here. The x68000 can have higher res screens, but I tend to aim for around 256. It can't do 320, it can do 256 or 512. 512 is too big, so we're limiting it to 256, but we're using the 240 height, which is an odd height, but perfectly good. So we're having to remap things a little bit just to reposition some of the fonts to make everything centralized and fit in there. Then we've got the screen definitions here. These are turning on the screen and setting the resolution. So if you wanted a high resolution, you'd need different settings. I've covered these in the simple series before, and there's a table with the various settings. But if you just want 16 color 256 by 240 mode, which is pretty much the best mode, I think, then these are what you would need to use. You'd need to turn some more on if you were using sprites, though. There is a sprite example on my website as well. And then we're defining the colors we're using here, and you can see very simple memory mapped addresses here, and we've got 5 bits per channel here to define the colors. So we're just defining the colors we're using for this here, very straightforward. Then we're clearing our game memory. We've defined an area called user RAM. If I just do a search for that, I think that's at the bottom. Here it is. So we're defining 256 bytes of user RAM. The game doesn't actually use that many, but it doesn't use many variables, this game. So I'm just defining 256 for safety, just a little bit of extra space. And then we're running the main menu routine in the multi-platform code, which does the title screen and things like that. Okay. So here's the main loop. Now, you remember that boost mode, I showed you that, and that's very important because the boost mode is basically where we update the player's movements every single tick. The normal mode we would only do every other tick, and the game tick is either a 0 or 1, and we're just dealing with that there. We then got a delay loop here, and in this we read the joystick and just see if any directions are pressed. We actually use a different delay depending if boost is on or off, and that's not really to speed the game up because that's what the ticks are for. It's because unfortunately the font drawing routine is a bit slow because we have to draw the old character in black to remove it and then draw the new character, and it's a pixel plotting routine, a little bit slow. So we've got a difference in speed depending on which whether we're showing the boost mode or not. So that's what's going on there. And then we've got a key buffer here, and if we read any controls in, we're going to store those in that key buffer. So here we're processing the keys and we're seeing if no keys are pressed, and if no keys are pressed we're going to clear the key timeout, and this is as I say, you have to release the direction and press it again to move again in the same direction, and that's what this is for. So the key timeout is cleared when the keys are released, and that will allow another movement to occur. So that's just our delay loop there. That's the start, and that's very straightforward. Then we're checking that key timeout, and if the key timeout is still set, then that key was never released, and we're going to skip to the next section. So the next section is of course the joystick reading, but just before that we're clearing boost mode by writing a 1 to the boost variable here. Then what we're doing is we're setting the memory address of the player direction variables to A3 and the acceleration to A6. Now the direction is going to be one of 4, north, south, east and west, for the rotations clockwise and counterclockwise. The accelerations are actually the movement for each tick of the game of the player. Now if the player's direction has changed, the accelerations need to be updated, and that's all done by set player direction. So we're checking for left and right here. This is left. I should have put an L there and an R here, that would have helped. So we're just checking the directions here, and if the player's moved left, we're decreasing the player direction, and if they've moved right, we're increasing it. And then we run set player direction, which will update the accelerations according to that direction. And then we're setting the timeout, and that will mean that the presses will be ignored until the key is released again. That's what I said. So that's what we're doing there. Then here we're checking the fire button. Now if the fire is pressed, we see if there's any boost power left. If boost power is not 0, then we have boost power, so we clear the boost variable and that turns boost power on. You'll notice we don't set the timeout because you need to be able to hold down the fire button to accelerate, otherwise you just move faster for 1 tick and you'd have to keep hammering away at the fire button, which wouldn't be much fun, so we're not doing that. Now the actual handling of the boost power, the movements and all that kind of wonderful stuff is done by the handle player routine, which is completely multi-platform, so we're not covering it here. Handle CPU does the same for the CPU, and this is all the collision detection and what have you. We then jump all the way back up here for the infinite loop. That's the main game loop, and that's all of the platform specific code for the main loop of the game. Just the joystick really, that's the intent of it, that's what we want. The less that's platform specific, then the less we have to rewrite when we port to all of the systems. This game works on 68000 systems, and it took about 2 weeks. I think it took less than 2 weeks to port it to all the different systems, and part of the problem with that was just each system's very different, and what works on one doesn't work on another, and things like the Neo Geo were a particular problem, and that one took extra time. But as I say, if you keep everything multi-platform and don't use the platform and keep the platform specific stuff in separate modules, then you just need to rewrite those modules, and that's what we've done here. Okay, so that's the main loop. What we're really going to have a look at is this PSET and this point routine, and you can see they're blooming tiny, which is good, and it means that there's very little to discuss. So what we're doing here is we're taking an X and a Y coordinate in pixels here and a color in D2 here. So then we're using get screen pods, and this is pretty much the same function as we used before in the simple bitmap routine tutorials. And we're taking our X and Y coordinate in pixels here. Now each pixel actually is contained in 2 bytes in a word basically within the memory, which is a bit odd, but that's the way it works. So even though we only need 4 bits, we're actually allocating 16 in memory, and basically the way the memory works is whatever the screen resolution, the color depth and things, it still uses the same amount of memory in the logical memory for the pixel. So that's a bit strange, but that's what we got. So we're basically doubling the X position to get the address of the X coordinate. We're going to add the screen base, that's at C and 5 zeros here, and then what we're doing next is we are going to basically take the Y coordinate, the line number, and we're going to multiply that by 1024. Now even though our screen is 256 pixels wide and there's 2 bytes per pixel, that should be 512, but as I say, it always seems to map to the maximum setting, which is at 512 pixels wide, so I guess that's 1024 bytes. So that's the settings we're using here. That will calculate our pixel position, and then all we're doing here is we're limiting to 16 colors here and writing the pixel to that position. Very, very easy. Reading it back, even easier. All we're doing is reading from the screen position the word, and we're loading that into D0, and that gives us the color of that pixel. Comically simple really, it's just that slightly odd screen coordinate setup that just we need to be aware of. And then we've got a clear screen routine here, and again we're selecting the screen base here, that's the start of the video RAM. Again, each line is 1024 bytes. There are 256 lines in the entire screen memory, and we're going to clear in longs in 32-bit blocks, so we're dividing by 4 here, and then we're doing the clear routine here, and that will clear the entire screen memory. Very straightforward again. The rest is all stuff I've covered in the other series, the simple series, and also in the Yquest game, so we're not going to go over them again. So I think that's all we're going to be covering today. I think, again, the x68000 is a really nice system to work with. I think it's a shame it didn't get more popularity in the West. Didn't get any, really. It's a lot easier screen layout to work with than the Amiga and things, so I personally find it quite pleasant. I'm planning on doing a tutorial later on how to use the multi-layer options, because the x68000 isn't limited to just a single bitmap layer. It can do multiple layers. Not something I've tried yet, but I'm planning to do so. So if you've liked what you've seen here, please hit the like button. That helps YouTube, recommends the video to more people, so that would really help me out. And if you subscribe, then you'll probably see that video that will be coming later with regards to the multiple layers. I've already done sprites in the past, but I've not done multiple layers, so you can be pretty sure that's going to be coming soon. Anyway, I hope you've enjoyed this today. Thanks for watching. If you've enjoyed this video today, please consider supporting my content. It takes 20 to 30 hours a week to keep making these videos. It's basically all I do when I'm not doing my day job, and it's only through the support of my patrons and the other sponsors that I'm able to continue justify doing it, essentially. You can back me on Patreon. I post a weekly update with the latest work on the current projects I'm doing. You can see one here, and also the newest videos. There's a large backlog of videos that are currently only available to the patrons, although they will all be available to everyone later on. And also it's the backers who I ask when it comes to making decisions on how to change the content in the future, what new content to create and things like that. You can see there was recently a survey of the backers, so I can plan next year's content. As well as Patreon, you can now become a member of my channel on YouTube. There's a join button you should see just below this video. You can use that. YouTube backers get the same content as Patreon. I just post it through the YouTube interface instead of the Patreon one. It's the same content every week. Also, if you prefer, you can go to my Teespring store and you can get some Chibi Akuma's merchandise or some Learn ASM merchandise if you prefer, if that's how you would like to back me. Links for all three are in the description of this video below. Anyway, whatever you decide to do, I hope you've really enjoyed this video. Thanks for watching today, and goodbye.